Mathematica and the Raspberry Pi. We're going to make a 3D plot of a vertical dipole antenna. We're going to start by making the polar plot in the transverse magnetic plane and a polar plot in the transverse electric plane, and then combining the two to make the 3D plot. We're also going to show how these plots can be done on a linear scale. We write the dipole transverse magnetic plane equation. We then make the polar plot and specify the range of the angle from plus and minus pi. And we end up with a circle. It radiates equally well in all directions. We can add a polar axis. We can add polar grid lines. We can add polar ticks and specify degrees. And we can add a plot label. We repeat this process for the transverse electric plane by writing the equation for it, plotting the angle phi from 0 to 2 pi, plotting it, and here we see two circles as if we're cutting across a donut. We add polar axis, we can add grid lines, we can add polar ticks in degrees, and we can add a plot label. This plot can also be done on a linear scale or a Cartesian graph, and we'll demonstrate how to do it first in radians and then in degrees. We start with the defining equation and simply plot it. We can then add our ticks, which will change the scale from simple numbers to whatever we want to put on it, in this case, units of pi. Insert grid lines. Add an axis label. Add a plot label. To do this plot in degrees, we'll simply do a cut and paste and change all the terms that are required. To make this 3D plot, all we do is take our two transverse plots, multiply them together, and plot them over the range of phi from 0 to pi and theta from plus and minus pi. We can then add a plot label, and we can add an axis label, of which there will be 3 for X, Y, and Z. And we're done.